Yes, Jai Hind everyone. I am Dr. Ashish Dixit, Associate Professor, Computer Science and Engineering, Ajay Kumar Garg Engineering College. So today we will discuss about the Hadoop ecosystem and yarn. Both topic is considered under the big data and analytics. So what is the Hadoop? And Hadoop is the technique that will handle to huge amount of data, how it will be managed, and Hadoop is a provide the ecosystem or an environment and also executed the initial phase to ending phase. So here we will cover some contents like a Hadoop ecosystem, yarn, differences between Hadoop 1.0 and 2.0, and also discuss with the Hadoop scheduler and types of schedulers. Okay, so here we will discuss about the Hadoop ecosystem, because the Hadoop ecosystem is neither a programming language, not a service. It's a provide a platform or like a framework where programming will be executed and problem will be solved. That's why Hadoop ecosystem provide some different types of component that will be used for execution of our any program. Okay, so here we will discuss about the some points like Hadoop distributed file system, yarn at another resource negotiator, MapReduce, here data processing using a programming language, and it's also use some alternative programming languages like Java, Python, C#, okay, PHP, and then next for I will use we will use after Spark. Spark, the purpose of Spark is provide a processing services like a data processing in memory. Then after we will use some concept PIZ and Hive. Here we will use a data processing services using a SQL or a HQL. Okay, so another resources we will use a HBase. Here we will use a NoSQL database, and then after I will use a Mahout Spark machine learning libraries, Apache Drill. Apache Drill also use SQL on a Hadoop, and here we will use a managing cluster that will called a Zookeeper. Okay, so for the processing, for the process scheduling, we use a Uzi concept, and for the ingesting the services of the data, we will use a Flume and Scoop. Okay, and for searching and indexing, we use a Solar and Lucene. In a last, we will use the concept maintain a cluster, provisions and monitoring the cluster. We will use a Ambari. These are a whole ecosystem of the Hadoop SDFS. So here we will use a concept that will be use first concept is also use a database, and here we will use a database, then use a HBase concept. In a HBase concept, we will use a NoSQL database. So here we will use a Hive analytical tools, and it's also used for a static purpose, not a dynamic purpose, and also use a HQL language, Hive query processing. Then second thing, we will use a scripting language that will be communicate from the client to server, and also use a PIG scripting language. Then after we will use these types of concept database scheduling, we will use the Uzi concept. Next thing, for the processing purpose of our data, we will use a Hadoop processing tools like a Hadoop MapReduce, and also use a Apache Spark. And second thing, a resource management. Suppose that we have multiple types of option for completing our work, and suppose that we have 4 to 6 multiple option. for execution of our any program. Then here we will use the concept of the yarn that's also manage the resource management, called the resource management. Okay, so here we will use a Hadoop yarn concept. Then after the resource management, we have a need to store our data. That data will be present on the e-commerce website, like a social media websites. That's why we will use the concept of the storage SDFS, Hadoop SDFS. Then in a last, how to inject our data, how to ingestion our data in a database, we will use some concept like a Flume, Scoop and Kafka. These whole things will be managed. These whole things will be managed by the Zookeeper. Zookeeper have the coordination work to all these concept. Okay, so here database, processing, resource management, storage and ingestion will be coordinated by the Zookeeper. So here we will discuss about the yarn concept. Then the main components of the yarn architecture include a client and resource management and resource manager. Client, the submit a map reduce job, and resource manager, it is the master daemon of the yarn, and it is the responsible for the resource assignment and the management among all the applications. Whenever it receives a processing request, it forward it to the corresponding nodes manager and allocate the resources for the complaint of the request accordingly. It has a two major concept. First is called the scheduler and second called the application manager. Scheduler will be schedule the different types of process. We can say that another language, it's called a scheduling. Suppose that we have 2 to 3 types of processes, and here we will manage the different types of scheduling, like a shortest job for scheduling, first come first service scheduling. Okay, and these types of scheduling will be managed by the scheduler. Second thing, application manager. It responsible for the accepting the application and the negotiating the first container from the resource manager. It also restart the application master container if a task fails. Here we will consider the next concept is a node manager. It take care of individual nodes on a Hadoop cluster and manages the application and the workflow that a particular node. Our primary job is to keep with the resource manager. It registered with the resource manager and send heartbeats with the health status of the node. It monitors the resource usages, perform a low management, is also kill a container on a direction from the resource manager. It also responsible for creating the container process and start it on the request of the application master. Then second concept is also called the application master. An application is a single job submitted to a framework of the application master responsible for the negotiating the resources with the resource manager. The monitoring process of a single application, the application master requests the container from the node manager by sending a container launch context. We can say that a CLC, which includes everything in the application needs to run. Once the application is started, it sends the health report to the resource manager time to time. Next thing, we will consider the container. A container is a collection of physical resources such as RAM, CPU, cores and disk on the single node. So here container are invoked by the container context CLC, which is a record that contains the information such as the environment variable, security tokens and dependencies. Okay. So this is the architecture of the yarn. So here we can say that we can submit an application to the resource manager by the our client. Okay. Then after we will use a resource manager concept. Here resource manager have a two component. One is called scheduler and second is called the application manager. Scheduler schedule the processes. These processes will be handle the different types of scheduling, and application manager manage the application that will be fetched that will be sent by the client. Then after these application manager are handled by the master node. Here master node should be sent to the resource application status to the our different types of work node. These are work node. So these work node also have a 4 types of block. First is called a data node, data manager, application manager and file block. After the sending the resource allocation status to the our work node, here a node manager will be handle whole things and send to the application master how to manage of this application. So here data node send the information to the file block. These process will be executed on the same manner, and here apply scheduling, and whole information again given by the resource manager. And then after the task assigned, here we will consider a task assigned status. This is called a task assigned status. So whole things will be called a yarn architecture. Okay. Next, concept of the yarn. First, client submit an application, and second thing, a resource manager allocates a container to start the application. I already discussed with this. Then here the application manager register itself with the resource manager. Then application manager negotiate the container from the resource manager. Then the application manager notify the node manager to the launch container. Next, the application code is executed in the container. Next thing, client contact to the resource manager and application manager to monitor the application status. And last, the once processing is complete, then application manager re-register the resource manager. So again, after the concept of the yarn manager, so here we will use some concept and also called Hadoop. And so here we will discuss the concept of the Hadoop 1.0 and Hadoop 2.0. Here this is the Hadoop 1.0. Here Hadoop 2.0. Okay. So we can say that now Hadoop 1.0 is also taken the support of the MapReduce processing model, does not support non-machine MapReduce tools. But here we will support MapReduce tools like Spark, HANA, Giraffe, message passing interface, MPI and H-based correspondence. So here MapReduce does both processing and cluster resource management. And in a Hadoop 2.0, we will use a yarn concept that at another resource negotiator does the cluster resource manager or management. Processing is done using the different processing model. Next thing, we will have a limit of the 4,000 nodes per cluster, but here we have a capacity approximately 10,000 nodes per cluster. Next thing, Here, work on the concept of slots. Slots can either a map task or a reduced task only. And here, we'll use the concept of the container on the behalf of cluster. So here, we'll use a container can run the generic task. Next thing, here we will use Hadoop 1.0 single name node to manage the entire namespace. But here in 2.0, multiple name node server manage the multiple namespaces. Next thing, we will consider Hadoop single point of the failure spoof because a single name node, and case of the name node failure needs to malware intervention of the overcome. In a Hadoop 2.0, we have considered features overcome of a spoof with standby name node. Okay, and in the case of name node failure, it is configured for automatic recovery, because without the recovery, without the backup, it's not a beneficial for our software management process. Here, a blockchain concept is also provide how to manage a huge amount of data, and recovery option is, if recovery option is not available, then it's a very worst position. If recovery option is not available, then it's a very worst condition for a big data management concept. Okay. Next thing, MR API is a compatible with Hadoop 1.0. A program written in Hadoop 1. Execute the Hadoop PLX without any additional files. Here we will use map reduce API requirement additional files. Program written in Spark and execute in the Hadoop 2.x. Next thing, it has a limitation to server as a platform for event processing and real-time operation. Next thing, can server as a platform for a wide variety of data analytics that run the processing, streaming and real-time operation. Here name node failure affect the stack, but here the Hadoop stack, Hive, PIG, HBase are all equipped to handle the name node failure. Does not support the Microsoft window, but here we can support the Microsoft window all time. Next thing, these are a basic concept of the Hadoop 1.0 and Hadoop 2.0. We can also use the Hadoop MapReduce. Hadoop 1.0 is a software framework for the writing the application that process huge amount of data. Second thing, yarn. Hadoop 2.0 is also use the concept of yarn at another resource negotiator to split the functionality of the resource management and job scheduling or a monitoring into the separate daemon that are resource manager, application master and node manager. In a yarn, we can use also resource manager, node manager and application master. So here resource manager is again a main node in the processing department. It receives the processing request and then passes the parts of the request to corresponding node manager accordingly. Where the actual processing take a place, the resource manager has two components, or that are scheduler and the application manager. Okay. Next thing, a node manager are installed on every data node. It is responsible for execution of the task on every single data node. And if you can say that the application master, then application master negotiate the resources from the resource manager and works with the node manager in order to execute of the monitoring of the task. Okay, so these are use the Hadoop scheduler. Here we will use some different types of scheduler. First, FIFO scheduler, fair scheduler, and a capacity scheduler. So here these scheduler will be handled by the job queue. Here we will use different types of task, task 1, task 2, task 3, task 4 and task 5. Okay. So these types of Hadoop scheduler, we have some types of concept like use a FIFO first in first out concept. Here we have advantage, no need for the configuration. first come first serve base and simple to execute. We have a disadvantages of this. The disadvantage of the priority of the task does not matter, so high priority job needs to wait, not suitable for shared clusters. Okay, so this is the FIFO concept. Next thing, we use a capacity scheduler. So capacity scheduler, suppose we have a knowledge related to potential of our any process. That's why we will use a capacity scheduler, that this process have a capable or a based on a performance that will be execute a task without the error. So here we will use a capacity scheduler. It's the best for working with multiple clients or priority job in a Hadoop cluster and maximize throughput in the Hadoop cluster. Disadvantage is it's a more complex, not easy to configure for everyone. Next thing, a fair scheduler. It is a very much similar that of the capacity scheduler. The priority of the job is kept in the consideration. In the fair scheduler, whenever any high priority job arises in the same queue, then task processed in parallel by replacing some portion for the already dedicated slots. So here the advantages of the fair scheduler is the resource assigned to each application depend upon its priority, and it's also have the limit the concurrent running task in the particular pool of for a pool or a queue. So disadvantage is it's also have the configuration is required. It's a more and more complex.